Hi everyone, I'm going to be doing pencasts, homework number 2, question 74. I've written the problem down here, and I'm just going to read it out loud. A physics professor demonstrates the Doppler effect by tying a 600 Hz sound generator to a 1 meter long rope and whirling it around her head in a horizontal circle at 100 RPM. What are the highest and lowest frequencies heard by a student in the classroom? So first we can just write down what our knowns are, and I'm just going to underline them right now. Alright, so our initial frequency of the sound generator is given, and that is 600 Hertz. Our radius of the circle is 1 meter long. And then our angular frequency is 100 revs per minute, given here. And then and we also know that the speed of sound in dry air at 20 degrees Celsius is 343 meters per second. And now we have to write down what we want to find. So we want to find the velocity of the speed, or we need to find the velocity of the source relative to the medium. So we can just put this as a question mark. And then we need to find the frequency at the highest and lowest frequencies. So this represent the highest, and F minus will represent the lowest. So first we can figure out the velocity of the source relative to the medium, and we can find that by multiplying the radius by the angular frequency. I'm just going to write that down. So our radius is 1 meter, and our angular frequency is 100 rev per minute. And then we need to convert this into the proper units, which is meters per second. And we can do that by multiplying by rad over 1 rev. So 2 pi rad is equal to 1 revolution. And then 1 minute is equal to 60 seconds. So we do 1 minute divided by 60 seconds. Now we can cancel out the units. So we can cancel revs. And then we can cancel out minutes. And this leaves us with meters and seconds as the units. Calculating this is 10.5 meters per second. After finding the velocity of the source relative to the medium, we can continue to find the frequency, the highest frequency, and that is given by this formula. The initial frequency of the sound generator divided by 1 minus Vs, which is the velocity of the source relative, divided by V, which is the speed of sound. and it's negative because the source is moving closer to the direction of the receiver. Now we can just plug in our values. Calculating this is equal to 620 hertz, and that is our frequency at its highest. And then we can calculate the frequency at the lowest, which is given by this formula. And this time we add because the source is moving away from the receiver. And this equals to 580 hertz. So, just to reiterate, the highest and lowest frequencies heard by a student in the classroom. The highest is 620 hertz, and then the lowest is 580 hertz.